All right, so our first speaker today, we have with us Dr. Stefan Bussmann from Germany. Hello, Stefan, and welcome.
Hi, thank you.
So Stefan is an IT project manager at Volkswagen in Wolfsburg, Germany, and he's responsible for introducing and maintaining tools like Parasoft C++ test or DTP. He studied computer science at Kaiserslautern and received a PhD from Southampton, and he's been with VW for more than 10 years now. So we're happy to hear, Stefan, about your journey, what you guys have done. Can you briefly tell us what type of development process you're using at VW?
Yes, we are using developing software mainly using agile processes like SAFe or Scrum. That's okay. Most of the development is now on agile processes.
And what were you doing in software that led you to look for things like Parasoft?
Yeah, well, the actual requirement to introduce this came from the business unit. Of course, I'm from the IT. But the motivation of the business unit, of course, is Volkswagen decided to develop software by themselves, or more software by themselves than they did before. And that implied, of course, if they do that, they would also need the same tools that other companies needed. So we built up a whole tool infrastructure so that we can build vehicle software with a lot more people than we did before. And one important aspect, of course, is to do testing and to check the compliance of the software. So that was a motivation to look for something where we can make sure that we have software of a high quality. And in the end, then we came to use Parasoft C++ tests, at least for the C++ test development. Not all of the vehicle software is written in C++.
All right.
A lot of.
Very interesting. So why don't you go ahead and share your slides, and I'll turn my camera off and we'll get going.
Okay. Okay, when we introduced C++ test at the Volkswagen Group, we experienced some challenges introducing the tool into the IT infrastructure of Volkswagen. And in my talk, I would like to explain what these challenges were and how we solved them. At the Volkswagen Group, we use C++ test and the DTP reporting engine for unit testing, test coverage, and static code analysis for the development of vehicle software. The tools are mainly used by the CARIAD. CARIAD is a subsidiary of Volkswagen, which was founded in 2020 in order to bring together all the software development business units which were scattered over the whole group into one company, so that this company could centrally develop the vehicle software and then deliver it to the brands, who could then ship the software with their vehicles. Now, when we provided the tools to the CARIAD, we experienced three main challenges. The first one was the secure authentication of the client. The second was mapping the product structure of our products onto the project structure of DTP. And the third one was enabling nightly builds. But before I go talking about these challenges, I would like to give you an overview of the setting we have at Volkswagen. Obviously, we have a software developer who is developing software, so he has a laptop with tools installed like IDE, build tools, compilers, etc. And of course, he has C++ test on his laptop. In order to use it, he needs a license, and he might also want to download root sets from the DTP server. What the developer does not is he doesn't upload the results of his tests, because that's what we do from the CI environment. So the developer checks in his code, and then on the CI environment, we have a crawler which calls for changes in the source code, and then calls a build job on a Jenkins environment, and which then also during the build process executes C++ test. And in that case, then C++ test will upload the results so that we get a full picture of the status of our of the software. Now, the first challenge we had with this scenario is the secure authentication of the client. And that is because we classify source code for our vehicles as confidential. And this classification entails a lot of security requirements. And the first one is that we require to protect our servers which hold the source code. And this includes also test results for the source code by firewalls and reverse proxies. Reverse proxy, you can think of an access gateway which prevents access for unauthorized users or systems. Now you might think that, okay, sure, you need firewalls when you want to access the systems from the outside, so from the internet, but not from the intranet, so within the corporate network. Now that's not true, at least not for Volkswagen, because our corporate network is quite large. For example, we have more than 100 locations worldwide, which all belong to the corporate network, and we have more than 50,000 clients. So you cannot really think of our corporate network as completely secure. So we need also these access gateways within the corporate network. The second and also very important requirement is multi-factor authentication. So when you access the source code, it's not sufficient to use username and password, because the password can easily be stolen. You just have to stand next to somebody who types in his password, and then you can see what he's typing in and you can reuse it. So we require that we use 2 factors at least. So for example, a smart card. So you have something physical which you have to put into your computer, and on the smart card there's a certificate, you need a PIN. That's the second factor in order to use the certificate for authentication. Or you can have tokens, or you can use your cell phone like for banking. So you have username and password, but you need a second token via your cell phone in order to authenticate. So we need multi-factor authentication, and if we're on a client, on a personal client of the developer, we also require that actually the user authenticate itself. So we cannot use a system user who does it for the user, but we need the user himself to authenticate. The third requirement is to have encrypted communication, but that's actually easily done nowadays. Now, if we now look back at the setup I explained, it gets more complicated. First of all, we have more firewalls inside and outside of the company. Now it makes a difference whether you're outside of the company or inside, or whether you're in the location in southern Germany or northern Germany, etc. And then, of course, we have these access gateways in front of the server, for example, in front of the DTP server. And this access gateway requires you to authenticate when you want to access the DTP server. And that was the first challenge. So the first challenge was to make sure how can we enable the C++ test client to authenticate, get through the reverse proxy, the access gateway, and then to access the DTP server or the information on the DTP server. And since we have reverse proxies in front of the server for all accesses to the server, so we had a security challenge on the client of the developer, but also on the CI environment. And there was a special case with container technology. Now I'm only going to talk about security challenge number 1 and 3, because the second one, if you solve the first one, the second one from the CI environment was actually easier to solve. But the third one gave us a headache. Okay, let's first look at the first security challenge. And basically, as I said, we need to do multi-factor authentication by the client. So whenever the client wants to access the information, he has to do this authentication. And there are widely accepted standards for this. For example, XAML 2 or OpenID Connect, which tell you how to do this. Now we chose OpenID Connect because it's a newer standard than XAML 2. So we looked together with Parasoft at how we could enable the client to run OpenID Connect. And OpenID Connect is very powerful, but it's a bit more difficult, and the protocol or the messages I'm going to show are actually a very simplification of the real protocol, because the real protocol actually has more than one token and a lot more messages, but the protocols are what I'm going to show is sufficient for the discussion. Now, what basically happens is the C++ test client wants to access the DTP server and will be rejected by the access gateway because it doesn't have a token. It hasn't authenticated yet. However, the access gateway tells him, okay, get yourself a token by accessing the identity provider. An identity provider means every company needs a system where it manages all the users of the company, and this system must be able to also to authenticate a user and then give him a token, a so-called access token. So what happens is, I access the system, I get rejected, redirected to the identity provider, C++ test opens a browser, because the redirect is basically a web page. So the user sees the browser, sees the web page, authenticates himself by whatever method he would like to use, and if that is successful, he gets a token. So we have the access token, and we could now access the DTP server. However, the access token is in the browser and not with C++ test. So the question was, how do we get the token from the browser into C++ test? And the standard OIDC doesn't tell you how to do it. It tells you everything else, but it doesn't tell you how to manage the access token. So what we did together with Parasoft, we looked at how we can do this, and we finally came up with a solution where we redirect the browser back to C++ test, which opens a small local server so that it can grab the token and then use the token and access the DTP server. And we also ran this through with IT security in the way, with some more restrictions we implemented. We were able to make sure that this is sufficiently secure so that we could roll this out within the company. So after working this out together with Parasoft, we were able to say, okay, now C++ test supports OIDC and we can authenticate. So we were happy, and we were also happy once we solved security challenge number 2 on the CI environment, until our business unit came up with a new challenge, because they started to introduce container technology, for example, Docker. And the reason why they did this is, before container technology, you had to install all the tools on each PC, on each laptop of the developer. And if you have so many developers, eventually you make a mistake and then you don't have the same version, or you don't have the same configuration. Something is not identical in one installation to another, and then you get different results. So sometimes this installation compiles it faster, slower, with different errors, etc. So with container technology, you're able to take a Docker, for example, a container, then install the tool chain on this Docker once, do all the configuration, then you distribute the container. And then everybody runs the chain in the build chain in the container with the exact same results, because it's the same installation. It's the same installation, it's the same configuration. So our business units really love container technology because it makes their job much easier. And they can also run the container on the CI environment, getting the same results also on the server. For us, it gave us a little headache, because what I just described, how we solve the authentication, doesn't work with container technology. Because the point is, the moment C++ test opens a browser in order to show the authentication page to the user, it does open the browser, but it does open the browser in the container, and not on the host, where the user could see the browser. Now, there are ways how the user could access the browser in the container, but this is not really comfortable, and you don't want to roll this out to 300 or 400-500 developers. So this wasn't really feasible. So the user wasn't able to get to the browser in order to do the authentication. So we had to find a different solution for this. And what we did after investigating how we could solve this, we basically introduced a helper tool. So what I just described, accessing the server, getting a redirect, open a browser, authenticating, getting a token, that's not done by C++ test. In the case, it's runs in the browser, in a container, but that is done then by a helper tool. And this helper tool now, in the same way, gets, after the redirect from the browser, the token. So the only thing we had to solve was, how do we get the token from the helper tool into C++ test, which is running in a Docker or in a container. And that is done a bit different, because containers or Docker works a bit different than, and therefore the solution we had is that we basically inject when starting the container, the token, via a socket, so that into the container, so that C++ test could grab this token and then finally access the DTP server. So the user has to start a helper tool before he wants to do C++ test, but that's actually quite easy to do. So this way he gets a token and he can use then C++ test in any Docker he wants. So that was the third challenge, and with this helper tool we were also able to solve this, and now we can use C++ test either directly on a laptop on the CI environment, or they can run it in a Docker. No matter how they do it, they can authenticate and use and connect to the DTP server. So that was the first challenge we faced. The third challenge was with our related to our product structure. If you look at our product structure, we have vehicle functions or customer functions, or the functions you experience when you sit into a car. And these functions are developed or implemented or divided into software components, and these software components are again divided into software modules. So you get sort of a hierarchy of components or parts which make up the whole function. And with the increasing complexity that we have in the car industry, these components are getting more and more, and they're getting more complex. So for example, for a larger component, a component could consist of more than 50 software modules. And a vehicle function may consist of 10 or 20 software components. So you get quite a lot of modules at the bottom, and also components which make up a vehicle function. Now, the software module is easily mapped onto the DTP project structure, because each software module is developed by a team of 5 to 10 people and is mapped onto a project in DTP. And then in this project, the team can configure their rule sets, create dashboards, and do their reporting. Now the question was, how can we map the software components and the vehicle functions? That was a challenge. And what we basically did, what we had to do is we had to look at how we could also do the aggregation of the information from the software module over the software component, so that we get a status of the software component, just as for a software module, and then aggregate it once more so that we get a status of the vehicle function. That was the challenge. The way we did this was that we, first of all, modeled all the users and groups that we needed for a project in an external user management system called LDAP. That's a standard for doing this. And we imported these users and groups through the LDAP interface of the DTP server. Then we mapped all the software modules onto DTP projects and assigned the corresponding groups. And now the challenge was to map also the components and the vehicle functions, and that we did through naming conventions and filtering mechanisms. So for each software component, we defined a filtering or a filter that was able to collect all the builds from the software modules and from the component, and then evaluate the information or aggregate this information in one dashboard. So if you look at the DTP server, you will find the filter on the right top corner. And what we basically did there is we programmed all the filters for the software modules, of course, but also for the components and for the vehicle function itself, and gave them specific names or following a specific convention, so that you can find the filter belonging to your module or to your component. Now that works. So at the moment we have a solution for this, which the users can use in order to do their job and look at the aspect or at the component they're interested in. However, if you look, for example, at one of our larger vehicle functions, you will see that, for example, or this function might have something like more than 2,000 users and something like 400 projects or modules, components, etc. And this results in more than 400 filters. And if you look at the list, of course you can search for the filter you're interested in, but of course that is not as ideal as you would like to have in particular if we want to roll the solution out to several vehicle functions in parallel. So concerning the mapping of the product structure onto the DTP project structure, we have a solution, but we still have some challenges to work with, and which we will look at in the future. For example, to improve the role model, because at the moment these filters have to be administered by the IT admin, and of course we want to delegate this to business unit admins, and we have to find a way how we can change, for example, that somebody only sees the filters he's supposed to, and how we can aggregate the information there. Now, the final challenge we had was enabling nightly builds. And the point behind this is that at the moment all our software developers are located in mostly in Europe. So we have something like we have developers working something like from 6 o'clock to 8 o'clock in the morning. But we will soon get additional teams which are in a different time zone, for example, India. And India is 4 hours behind, so we get something like the first developers start at 2 o'clock in the morning if I look at Germany, German time. So they start at 2 o'clock because they already have 6 o'clock in the morning. And then we get people working with DTP from 2 o'clock in the morning to 8 o'clock in the morning. And if I now want to start nightly builds, in the sense that I want to run full builds every night in order to get to see whether they are error-free and to see what the test results are, run all the tests also every night in order to see all the compliance checks, in order to see what the status of my software is, so that the next morning I see, okay, yeah, I improved, or something is wrong, something got worse, so that I have a faster reaction time and a way to improve the quality of my software. Then I actually get the point that if they start at 8 o'clock running their full builds, and some of these full builds, especially for our larger ECUs, they might take up to 8 hours, even if we parallelize the build process. Then we get the point that we start at 2 o'clock in the morning for some people. In India, we have people working until 8 o'clock, then we run the full builds, and these builds take until something like 4 o'clock, 5 o'clock in the morning. So the bottom line is we actually run DTP round the clock. And the challenge with running it round the clock is that I don't have any time to do a backup. And maintenance I can do on the weekend because they are doing the development during the weekday, so Monday to Friday. So they don't run their builds on the weekend, but during the day I can do my maintenance. But backup I would like to do every night. And that I cannot do if they're running it 24 hours a day during the week. So the challenge was to implement an online backup in the sense that we don't stop the DTP server, so that people could continuously work with it. And the challenge with that is that DTP does not only have a database, of course it also has a file system. And the solution was to do a snapshot of the file system so that we can do this much faster. Because before, we stopped the DTP server, we did the database dump, we collected all the information in the file system, which took quite a few hours, and then we started DTP again, meaning we get a downtime of 3, 4, 5, 6 hours during the night. And now with the new solution, we stop the DTP server, we do a snapshot of the file system, we start the database dump, and we can start, and then we restart DTP because while the database dump is going, we can restart DTP. That doesn't, they don't bother each other. And then DTP is running again, and we can do the actual backups or copying the data to a backup location in parallel to DTP continuing to run. So we have a short downtime, but the downtime for doing the snapshot is something like only 5 to 10 minutes. So, and the Jenkins jobs, they are tolerant to a small downtime of 5 to 10 minutes, so they don't care if there's a short downtime, then they will try again, and then after 10 minutes the DTP is up again. So that was the third challenge we solved, so that we could provide around the clock working for our business units. Okay, so these were the 3 challenges we looked at, and of course there are still some challenges to go. I will only mention 2 of the ones I listed here. The first one is with rolling out DTP to more and more business units and developing teams. Of course, and with the nightly builds, we create more and more data. And the point is, of course, many of these nightly builds you don't want to keep. They're just in order to give you a fast impression whether you are improving. Of course, some of these builds are the final builds where you deliver software, and these are you want to keep in order to prove that you did all your testing and you did a good job. But a lot of these builds you don't have to keep, and they just clutter your database after some time. So one challenge we still have is to see how we can do housekeeping so that we can delete data which is no longer needed. And the second big challenge we are looking at in the future is, of course, the information about unit testing and compliance is very important to understand the quality of the software, but there are also other analysis tools which we have to run, for example, open source scans or security scans, etc. And we would also integrate this information about the quality and the results of the tests, etc., into our ALM solution, so that we can see what are the requirements we had, what were the test cases, they were all run, and were all executed, they're all positive, etc., and we get all the other information so that we can in the end give a final approval for software. So another big challenge is to integrate the results which we get from C++ test and DTP with the other tools and the other process steps on the road to a final software. Yeah, that was what I would like it to show, and thank you very much for your attention.
All right, thank you, Stefan. That was fascinating. You can turn your camera on if you want, and we can take a few questions. It's always fascinating for me to see, like real world deployments following the real kinds of challenges that people have, rather than just, hey, here's a little team. It's pretty easy to get things going. There we go. So, yeah, to me, it's fascinating to see, like you have here a real global team, people in different time zones running a secure development process 24/5. So it's pretty interesting, I think. One of the questions that came in, it says, it looks like VW is heavily investing in Agile. If so, what's the reason for this?
Well, first of all, that's true. Volkswagen, at least all the development teams that I know, they are running Agile development, so Scrum and Safe. Not only Scrum, because they are very large teams, so you can run Scrum for like 5 to 10 people, but sometimes some of these developments have 200 or 300 developers, so you run Scrum or Safe. But the basic reason is that the experience that we have within the company, no matter whether it's enterprise IT or whether it's the business unit, that with today's fast development, you cannot run a waterfall approach. So we need this agile method so we can get much faster, we get much faster feedback, like the MVP concept, etc. So you get systems which you can try out and so on and so on. So our experience is that we are much faster and also create better quality when we run it in an agile mode.
Yeah, I can see that. One of the questions says, I'm curious about the tangible benefits you're seeing from this effort. Your slide talked about further expansion for use of the tools, and how broadly do you expect to adopt them?
Well, the idea, of course, we are not completely there yet, is of course that you start from the requirements, what you're trying to develop, and then run through the whole process. And so that in the end, you can have somebody who looks at the results, like I mentioned, in the end, you can say, okay, now we did everything, we did the requirements, we did the testing, we did the compliance checks, etc. And then you can say, okay, now I can approve the software. And for doing this, he, of course, in the end needs the full, complete view of what has been done. So we have to integrate all these different components so that in the end, the responsible manager can make this decision that we can roll it out. And that is something, of course, where we still have a challenge because they are not all that integrated and able to exchange all this information, in particular in the way that you can associate the information and understand what this particular information you get means.
Yeah, and in the end, though, you have a really global view, right? Like a unified view when you get everybody working the same way.
Yeah, to explain, the project manager in the end has to decide that he has like 50 modules and 20 components making up, even if he's only responsible for one vehicle function. He has to decide and say, yes, this vehicle function I can roll out in our cars. And this is a quite complex story he has, or he has to look at all this information and make sure that everything works together, and this is a quite challenging task. And for this he needs this information aggregated in a form that he's able to assess whether it's okay or whether it's not okay, and they have to keep going.
Yeah, absolutely. Another question says, you mentioned using DTP as well as C and C++ test. Can you explain how that helps you and whether it's something I should be considering for my deployment?
Well, C++ test, of course, is the main component because it supports us in doing the testing, supports us in doing the test coverage and the compliance. So, of course, that's the most important component. Without, we wouldn't achieve our goal. But DTP is very important for us to aggregate this information. Excellent.
And what aspects of C and C++ test are you using? Is it static? Is it functional? Is it metrics? Is it unit testing, etc.?
Well, we do unit testing, at least for the newer components, because some of the legacy systems that they have been using before, and they have, of course, a lot of work to switch to the new tool. But for sure, what we do is test coverage, and we do static code analysis. So we have things like MISRA, also security rules that come with C++ test, which we are running to make sure AUTOSAR is very important, of course. And so at least for all the tools or all the components, we do test coverage and the compliance checks in order to make sure that the software quality is sufficient.
Yeah. Well, thank you very much, Stefan. It's been a pleasure to have you with us today. We're so grateful that you could take your time and wish you the best of luck with the new vehicles.
Thank you. And thank you for giving me the opportunity to talk here. Thank you very much.